Hello everybody. In this video, we are still talking about the distillation in Aspen Plus, and we are gonna um, talk more about the calculation type option here. So this is something that we talked about in the previous videos, and we mentioned quickly the difference between the rate-based and the equilibrium stage calculations in the sense of the type of calculations that are being done. But we have only used the equilibrium stage calculations, and we showed that this is not an actual uh, case, or not, there is no actual equilibrium that's taking place. That's why we do define the stage efficiency or the Murphy efficiencies. So we're gonna go for the rate-based calculations, and we will see, I'm gonna do my best to focus on 2 points. The first is the difference in the inputs between the rate-based and the equilibrium-based calculations, and the difference in the outputs. There is gonna be a big difference in the inputs between the equilibrium and the rate-based. So this is something I'm keen on highlighting and making clear as much as I can. Um, Before I start, I have deleted the column internals that I made in the previous video because I need to start from scratch. So this is something that I want to uh, make you aware of. So what I'm gonna do now is I'm gonna go for the rate-based calculations, and once I choose the rate-based calculations, you'd see that these two parts uh, are not satisfied. They need more information, the column internals and the rate-based calculations. Before going to the column internals, I want to just take a look at this. This is a global setup, which is set of parameters that we provide to kind of give information about the mass transfer and the factors for the transfer coefficients. Or I don't actually uh, understand each one of them, uh, but I think these are mass transfer parameters that are kind of, you can find values for them for specific cases, or for specific materials or specific flow regimes. I don't know. So this is something that you can search for if you're interested. But the point that's kind of confusing here is that you have all these tabs filled with values, and you cannot see any one of them that is empty. And however, the tab is red, and it's saying that something is missing, and this is kind of confusing. But actually, there's nothing that you need to provide here more than this. uh, the problem is in this tab, which is the sections tab, but the sections tab is inactive because it depends on the column internals. So the inactive tab cannot have the red sign here. So the red sign is here because it cannot be put here because this tab is not active. So we need to start for the column internals, and once we're done, you will see that this is done, and this is the red sign is here. So I'm gonna go for the column internals, add a new set of internals, and then auto sections as we did before. And here is one of the first differences between the equilibrium and the rate-based calculations. In the previous video, we saw that this button, when we clicked on this button, it generated or created the sections the same way here, but it calculated everything. It generated information for the column diameter and the weir heights and all these kind of information. But this is not the case here. It didn't do anything, although it is in the interactive sizing mode, which is the same case that was in the previous video. And the reason here is that you have to have one at least one of the sections in the rating mode. Before I choose this, I want you to take a look at the sections here. I have the two sections are incomplete. The information are incomplete for both. If I choose the second to be in the rating mode, the first would be done. So you do not need to provide information for the whole column. At least one section must have internal information, which is what we did here. If we flip and do this as rating and the second as sizing, then the sizing would be fine and the rating would not be fine. You have to provide information for this. So this is kind of weird, but this is kind of something that we should expect, that in a case like this, when we are doing mass transfer calculations, we should provide information about the place where the mass transfer will occur, the shape of the bubbles, and all this information depends on the internals of the column. So I have to provide some information about it. Um, so I'll keep one in the rating mode and one in the sizing mode, and keep in mind that the first section is in the rating mode because we will need this information in few minutes. So the first is in the rating mode, and I need to provide information for the first section. I don't need to provide like a bunch of information. Here you can choose if it's in the interactive mode or sizing mode or in the rating mode. You choose it if it's tray or packed, the type of tray, bubble cap, sieve, whatever. You need to provide the hole to active area. It should be something around 0.05 to 0.25, so I'm gonna put 0.2. And the diameter of the column, I'm just putting any numbers from my head, so they might be not true or not right, and this most probably the case. Um, and here I'm gonna put the side down camera width. You'd see that these two, when I click on here or here, that both will be highlighted in red, in yellow, and this means that you need to provide one of them, not at least, but one of them must be provided. So I'm gonna put 2 feet, and this is enough. You can provide more information here, but in this case you need to provide the diameter, the top down camber width, or the side weir length, because they are dependent. So because the down camber is what we have between the weir and the side of the column. So both are dependent. So if you put one, then the other can be easily calculated. So now these are the information that you need to provide, and it's now happy. Now let's go back to the rate-based modeling. You'd see that this is now done, although I didn't do anything here. But let's go to the sections. You'd see that there's 2 sections here, and it's allowing me to do the rate-based calculations for CS1, which is the first section, which is the section that I provided information in. So this is important, that if in case you put the CS2 as in the rating mode, you will have the option to, or you don't have the option, you must click on this. I don't know why it's not done automatically, but it's like this. And here, when you click on the rate base, it will tell you that you must also check the rate based calculations. I'm now in the third line from the bottom. You must also check the rate based calculations on tray rating, pack rating section, or rate based setup in the sections form, which is this. Uh, the rate based setup in the sections, you have to check this. So there are a lot of informations here about the non-ideality. There are correlations for non-ideal behavior, the resistance for the films, and all these things that you can consider the film reaction. In case of reaction, if you have resistance to mass transfer, then you can consider this. So again, this depends on your information, on your case. So it totally differs according to different cases. Anyway, so these are the two parts where we have difference between the equilibrium and the rate-based calculations. And once we are done, we can click on the run button and see what we are gonna get out of this. So now it's generating results, and we'll see what we have. Again, the results will be similar to the results we got before. Here you have the duties, you have the reflux ratios, the reflux rate, all the information. For the split fraction, it's done. So still we can have the design specs going here in this case as well. We can still see the profiles for the temperature, for the pressure, for the K values, for the hydraulics, for everything is working as well. But the point that might be new, or before this, when we do the column hydraulics, we see that uh, it's giving us the same thing. The parts of the column are operating well and parts are not. And of course, because I'm putting information from just random numbers, we will see that there are some errors here. I'm operating out of the range. Um, it might be a good thing to generate the internals uh, from the equilibrium based calculations first, so that it calculates some realistic values, and then you turn to the rate based calculations and use them as inputs to use in this case. So this might be one thing that will save time. um, the last thing I want to mention is the report, yeah, the rate-based report. You can choose to provide information about the interfacial compositions, which is the composition at the interface between the liquid and gas phase at each stage, the area, diffusion coefficients, the mass transfer rates, the dimensionless numbers, and this is what you can see here. For instance, here for the dimensionless numbers for the vapor phase, you can choose the Schmidt number and the Sherwood number. um, and, uh, and this is great. You can have this for each one of them. This is the liquid Reynolds number, the vapor Reynolds number, the Froude number. There are a lot of dimensionless numbers that you can have for each one of the trays. We have here. Uh, this is one section. I think it's doing this for each section separately. Um, so you can have a lot of information based on the stage, or this is all for section one, so we can do this for section two as well. Um, anyway, so this is one thing, the transfer coefficient, which is oh, I'm sorry. This is done for section one because the section one is the section that was in the design mode, in the rating mode. It's not in the interactive design. So it's doing this for the rating mode. I missed this. Back to the sections, we have this in the rating mode for section 1 from tray 2 to tray 49. So all this information are only available for tray 2 to tray 49. The transfer coefficients, which is the binary diffusion coefficient, which is the diffusivity, and it's amazing to find this, the diffusion coefficients. I personally see this as like a tough thing to calculate. So you have already all the values here. It's giving zeros for the same species because there is no transfer coefficient between styrene and styrene. It should be between two different things. Here for the temperature, for the composition profile, for mass transfer, you'd see the mass transfer rate, the interfacial area, and this is amazing. You can see the area of mass transfer for each tray, which is great. Um, so this is almost everything for the distillation in the rate based calculations. I hope it helps, and I'll see you in the next video, inshallah. Goodbye.